Welcome to graphing quadratics using step patterns today. Okay, so we're going to do a little bit of a review, but we're also going to kick in some of the step pattern info. We covered this last lesson where I was showing you how to graph the parent function and that there's a step pattern with the points. So we're going to use that to graph these other ones where they've been transformed today. Okay, so we'll start off with the parent function here, y equals x squared. I already have a nice graph in here so that I can show you the step pattern a little better. So we'll start analyzing the parent function, looking over things like the vertex, axis symmetry, etc. So we'll go over here and start adding this in. So we have the vertex is at 0, 0, whoops, 0, 0, and the equation for the axis of symmetry is that x equals 0. Okay, so now we're going to analyze the step pattern again. So I'm just going to zoom in here. Okay, so looking at the parent function here, we are going to analyze the step pattern. So we're going to start at the vertex, and we're going to go over 1, and then we're going to go up 1, okay, to the next nice point. Okay, then we'll go over 1 and then up till we hit it again. There it is, this point here. Over 1, up, there. Okay, so we're going to analyze our little steps here. So every time, so starting from the vertex, every time we went over 1, we're going to count how many squares we went up. So in this first one here, we went up 1. Okay. Then we went over 1 from that point, and then up 1, 2, 3 squares here. Up 3, over 1, up 5, etc. Okay, if we have more graph, the next one would be up 7. This is our step pattern. Okay, so we'll zoom back out. And we'll fill in the table here. So the step pattern here was 1, 3, 5, etc. All right, so we're not going to write in the description of the transformation because this is the parent, this is the original. Okay, so now we're going to, just putting on some arrowheads here. Now we're going to move on to the next one, y equals x squared plus 3. Okay, so we'll analyze, so again, from your investigations from last day, hopefully you can predict where the vertex and the axis of symmetry are, and then from there, I will help you look at the step pattern. So the step pattern is based on the value that is sitting right in front of the y, or the x squared here. So in this case here, if I were to draw it in, it's a 1. Okay, there's a 1 here. It's kind of a big one, so let's put a 1. Okay, so we're going to look at the next one here, and again, it's just a 1 here. Okay, so the step pattern will still be the same. The thing that will change here is that this this graph here has now moved up by 3. So all the points in the graph will move up by 3. So we're going to quickly graph that. So we'll start with writing in the vertex. Okay, so we know that it was this graph, but it moved up 3, so the vertex should be, so from here, it moved up 3. That's what will happen here. So the vertex will now be at 0, 3. Okay, the axis of symmetry, still the same spot. Okay, and like I said, the step pattern is still going to be the same. So it'll still be 1, 3, 5, etc. Okay, so we're going to look at describing it in a second. So let's get this plotted first. So you're going to look at, this is where the vertex is 0, 0. So when we move it here, it'll be right there. Okay, so 1, 2, 3. So this is where the vertex will be. So this graph here, the parent graph here will shift up 3. So we know that the step pattern from the vertex is 1, 3, 5. Okay, so from here we're going to go over 1, up 1, over 1, up 1, over 1, up 1, and it's a really quick way to plot the other points. So let's do that right now. So again, I have my vertex right there, so I'm going to go over 1, up 1, and put a dot. Over 1 from this one, okay, and up 3, 1, 2, 3, put a dot. Over 1, up 5, well, I'm going to run out of space, but I guess I could just do a rough point there, okay? And we're going to do the same thing on the left, from the vertex again, over 1, up 1, over 1 square, up 1, 2, 3, because the pattern is 1, 3, 5, right? So over 1, up 1, 2, 3, 4, 5-ish, right there. And then we have our graph that we can plot. So let's connect the points here. Okay, and there's your new graph. Okay, so now if we analyze the information here, so we know, yep, the vertex is at 0, 3, the axis symmetry is at x equals 0, the step pattern was 1, 3, 5, as you go over 1, up 1, over 1, up 3, over 1, up 5. Okay, so how will we describe this? We know that the only thing that changed here was this plus 3, so it was a vertical translation up by 3. Okay, so that's a fancy way to say it. I will accept up 3. Okay, so let's try the next one. Okay, so x squared minus 4. So the key here is that you should be able to predict where the vertex is. And then from there, then because we know that there is a 1 in front here, that we know our step pattern is 1, 3, 5. Whenever there's just a 1 in front, 1, 3, 5. All right, so the vertex here, so we know that this subtract 4 on this graph or equation here means that it's going to slide down 4. Okay, it'll still look the same as the parent, it'll just be down 4. These are slightly different scales, and that's why this one looks a lot bigger, but they should be the exact same. Okay, so we'll try red. Okay, so the parent vertex is always at 0, 0. We know that this is going to slide down 1, 2, 3, 4. And this is where the new vertex will be. So from there, the step pattern is go over 1, up 1, put a point. The next one, over 1, up 3, put a point. Over 1, up 5, and put a point. And over 1, if we had 7 spots, be right there-ish, okay? Then we get the other point. All right, so same thing on the other side, over 1 from the vertex, up 1, over 1, up 3, over 1, up 5, over 1, up 7. Okay, and then connect the points here. Okay, and here's our label already, so I'm not going to write it in again. Okay, so then from there, let's fill in the vertex information. So we have the vertex is at 0, negative 4. The axis of symmetry is still in the same spot, right? We didn't move left or right. The step pattern was 1, 3, 5, 7, etc. You can just write 1, 3, 5. And then if we're describing it, it is a vertical translation down by 4. And again, I'm okay if you write down 4. Okay, let's move on to the next page here. So that was up here, this was the translations, so going up and down. So now let's analyze going left and right, horizontal translation. So again, here's the parent graph. Okay, so we know our step pattern now. We know the vertex is always at 0, 0, axis of symmetry, and the step pattern 1, 3, 5. So again, we analyzed the fact that there is just a 1 for the A value, right? So here we know the A value is equal to 1, so the step pattern is 1, 3, 5. Okay, so let's just take a look here. So again, the key here is just figure out where the vertex is, make sure it's correct. And then from there, you can use the step pattern 1, 3, 5 to quickly graph the equation. So again, you don't need to make a table of values. You just need to find that vertex and then use the step pattern 1, 3, 5. Okay, so again, analyze it. So it's plus 5. Which way did it go? It went left by 5. Okay, so plus 5, left by 5. So over here, let's plot that in. There it is. There's the vertex. Okay, so then use our step pattern trick. So from that point, over 1, up 1. Over 1, up 3. Over 1, up 5. 5. Okay, and then on the other side as well, over 1, up 1. Over 1, up 3. Over 1, up 5. And then connect it up. Okay, extend all the way through the graph, arrowheads, smooth curve. Okay, there you go. And then fill in your information here. So the vertex is at, so remember it's shifted to the left, so negative 5, 0. So when that happens, the axis of symmetry, so again, remember when we used to do this? We used to draw the axis of symmetry line in. Okay. So the axis of symmetry will also shift. So always look at the x value of your vertex. That is what your axis of symmetry equation will be. Okay, and then again, our A value, which is right here, right? So that number that's sitting right out in front of the x squared is 1. There's no value there. There's no negative there. So the step pattern is still the same. And so we're going to describe it. So again, if you wanted to use all the fancy words, it's horizontal translation. To the left. By 5. Okay, don't put in the negative. Or I'm okay if you just write left 5. All right, move on to the next one. So again, you should be good at predicting where the vertex is. Okay, so this the horizontal translation always messes up people, so make sure you know, okay, if it's plus, go to the left. Okay, if it's subtract, go to the right. Okay, so again, analyze this one. Work ahead of me if you want. And then, okay, so we know it's subtract 3 here. Okay, it's in brackets. All right, that's a horizontal translation, 3 to the right. So putting our dot here. And then from there, we know that the A value here in front is just a 1. So step pattern is over 1, up 1 from that vertex, over 1, up 3, over 1, up 5, etc. Okay, and then same with the other side. There it is. And then connect it together, nice smooth curve. Getting better every time I do this, I think. All right, and arrowheads. Looks kind of like a V here. Smooth it out a bit. Okay, so from there, tell me the vertex, all that stuff. So we know that it shifted to the right by 3. Okay, it didn't move up or down, so that's why the y value is 0. You know, the axis of symmetry is the x value. Okay, and I can't remember. Just look at the graph and go, yeah, see, it's at 3. and the step pattern was 1, 3, 5, and the description would be, compared to the parent, y equals x squared, it went right 3. Okay, moving on to part C. So we analyzed this again last day, but we're going to analyze it using step patterns now. So again, we were always looking for the a value. Okay, so in this case here, it is positive 1, and then here it's a negative. So what number is actually sitting there? A negative 1. And I just add those in. Okay, so you know, like there's a 1 here, and then think of this as being like a negative 1 sitting out here. Okay, so let's go through and analyze the parent again, just so we have a baseline, something to compare to. Okay, so there it is. Vertex is 0, 0. Axis of symmetry is x equals 0. The step pattern is 1, 3, 5. Okay, so again, we know our a value for this one here is positive 1. So now when we're looking at the next one here with the negative in front, how does that change the graph? Okay, so again, hopefully you can predict what that'll look like, but let's look at it from the perspective of step patterns. So the vertex for this one, it didn't change, right? There's no vertical translation value. There's no number in brackets here, so there was no horizontal translation, no left-right movement, no up and down movement, just this negative. So our vertex is still in the same spot, so let's just put that in. So it'll still be right here, okay? But then let's just go right to analyzing our step pattern. So in our equation here, again, there is a negative 1 sitting out front, right? This one had a positive 1. So when we go down here, you know, we can kind of fill these in later, but right now let's look at the step pattern. So we know our a value is, our a value is negative 1. Okay, so how step pattern works is that in general it's always the default is a 1, 3, 5, but what you're going to do in order to calculate the step pattern is you're going to multiply whatever the a value is to the step pattern. Okay, so back up here, the a value was always 1. So it's like we took 1, 3, 5 and multiplied by 1. So that the step pattern didn't change. Here, same thing, the a value was always 1. We multiplied this by 1, 1, 3, 5, step pattern, the step pattern was always the same. Okay, but now we're getting to where the a value is different. So for this parent graph, the a value is 1, so when I multiply this by 1, I get 1, 3, 5. Here the a value is negative 1. So I need to adjust my step pattern. What I'm going to do here is I'm going to take negative 1 and I'm going to multiply it to my step pattern, 1, 3, 5, 7, etc. Okay, so my new step pattern for this graph here will be negative 1, negative 3, negative 5, etc. So if we go about, go and graph this now, how does that look? So what you're going to do here is, again, look at the vertex. Okay, we determined that this didn't move left, right, up, or down, so the vertex is here. So we always go over 1, and then we went up 1, over 1, up 3 before. But the step pattern here is saying over 1, negative 1, over 1, negative 3. So you need to go over 1, down 1. Okay, over 1, down 3, over 1, down 5. So over 1, down 1. Okay, from that point, over 1, down 3, over 1, down 5. Okay, and then again, the other way, over 1, down 1, over 1, down 3, over 1, down 5. And hopefully you're, as you're going through, you're thinking, okay, this is a lot faster than what we were doing the other day where we're building a table of values and plotting all the points and getting to there. So this little step pattern, makes graphing a lot quicker. Okay, and there we go. There is your negative x squared. Okay, so that makes sense. That is a reflection in the x-axis. Okay, so the x-axis is like a mirror. The parent graph is flipping through the x-axis and reflecting on the other side. So we call, whenever you put a negative in front, you get a reflection in the x-axis. And make sure write x because next year there's a y-axis reflection. All right, fill in the rest of the table here. Vertex was 0. The axis symmetry still the same spot as well. Just the step pattern changed, and therefore the way you describe it will change as well. On to the stretches and compressions. We're going to do them together here. So again, we're going to try to graph these quickly. It is dependent on where the vertex moves. That's what you have to find first. And then you have to figure out what does the step pattern look like. Okay, so here's the parent here. So we're just going to remind you that it has a 1. Okay, so the A value is 1. Okay, so from there, vertex, axis of symmetry, and the step pattern. So think of it like, okay, I have to find the A, it's 1. So then I'm going to take my A and I'm going to multiply it to my step pattern. Okay, and so 1 times 1, 3, 5, etc. is 1, 3, 5. Okay, so that's my step pattern. So that's what you're doing here. So take a look at the next one here. We have the A value is 2. So we need to, let's use that color. Okay, so A value is 2. So again, it didn't move left or right or up or down, so we know the vertex is at 0, 0. Okay, so, but let's figure out the step pattern first. So we know the A value here is, 2. So our step pattern becomes 2 times 1, 3, 5. So therefore it's 2, 6, 10, etc. Okay, so let's look back at the graph here. So here's our vertex. Here's a new step pattern that we determined for something that's multiplied by 2. Okay, so let's plot it now. So over 1, up 2, over 1, up 6. And we won't be able to plot the up 10, so we'll just plot these ones. Okay, so again, oops, wrong spot. Again, I just want the vertex and a couple points around on the left and then on the right, so 5 points. If you can get more than that, great, but just that's good. Okay, so let's connect these up. Nice smooth curve. And then we get our equation there. All right, so again, compared to the parent, it is vertically stretched. So if you were to draw it on here, you would see it on the inside of this parabola here. It's vertically stretched, okay, by a factor of 2. Okay, so these ones here, I can't, I don't want you abbreviating or shortening them, so you have to write vertical stretch. Okay, so that'll get you 1 point, and then to write by a factor of 2, that's the other point. Okay, so make sure both of those, all of this is here. Okay, so the vertex here, still in the same spot. The axis symmetry, still in the same spot. Okay, so let's try the next one. Okay, so here, analyze the A right away. Okay, we got 1/2. Right, we don't have any left or right movement, no up and down movement. So the vertex is still the same spot. Okay, let's go analyze the step pattern. So again, it's 1/2. Okay, so I'm okay if you guys want to go to decimal for these, just because we have to try plotting them. Okay, so so you have 1/2 or 0.5 times 1, 3, 5, 7, etc. Okay, so if you're multiplying by 1/2, it's the same as dividing by 2. So you're going to get 0.5 etc. So from there, let's plot these. Okay, so you have the vertex 0, so you're still, so from the vertex, you're still going to go over 1, up, whatever the step pattern says. So in this case here, it's you're going up 0.5 for the first one. Then you still take a full block over, go right 1 from wherever that point is, and then up 1.5, over 1, up 2.5, etc. So let's do this here. So from the vertex, over 1, up only 1/2. Okay, so again, remember you start at that point, over 1, up 1.5, which will be here, okay, because that's 1.5. Over 1, up 2.5. Over 1, up 3.5. Okay, and do the same thing here, up 1/2, over 1, up 1.5, oops, over 1, 2.5, over 1, 3.5. Okay, and connect them up. Okay, so this one is y equals 1/2 x squared, so think of it as half the power of the parent. So the arms will be compressed, where the 2x squared here, it was doubled, so the power to pull up those arms doubled, so it'll be higher, straighter up, where these ones are compressed. Okay, they're drooping more. Okay, so fill that in. Okay, proper terminology, vertical compression. Okay, by a factor of, okay, so again, like I was saying, just look at the bottom of the A, or if, sometimes if you get a fraction like 3 over 4, you don't want to do that, so just flip the fraction. Okay, vertical compression by a factor of 2. That takes us to the end of graphing quadratics using the step pattern. So I want you to go and practice the worksheet that I'm providing, and then when you feel confident and good, try the checkpoint.